Hello, this is NCKU Tainan, and you are now watching the demonstration video of our nitrate regulation system. Before we start, let's take a look at the diagram of our device. Our regulation system consists of several elements, including one regulation box, two coarse filters, two bacterial filters, one UV light, and two water pumps. The regulation box is where we put our regulation E. coli, which is the core of our regulation process. In our No Problem project, we plan to put this regulation system beside the fish pond. It can downregulate the nitrate level of the pond water if the fish farmer received an alert from our nitrate detecting system. So how does it work? The green barrier you see now represents the fish pond, and the water in it will be pumped into our regulation system. At the very first step, the water will go through a coarse filter, which should stop the big impurities. After meeting with the first pump, the water will be squeezed through the bacterial filter. This bacterial filter acts as a guard to prevent our regulation E. coli from escaping through the inflow passage. Finally, the pond water enters the regulation box, ready to be regulated by our E. coli. Now let me explain what is E. coli doing in our box. There are three enzymes constructed in our bacteria, including nitrite reductase, glutamate dehydrogenase, and glutamine synthetase. The nitrate will be transformed into nitrite by a nitrate reductase cluster, which already exists in E. coli naturally. After that, nitrite reductase will turn nitrite into ammonia. Ammonia will be quickly taken as a reactant to form glutamate by glutamate dehydrogenase. In the end, glutamine synthetase will catalyze glutamate into glutamine, which is a common seen and valuable chemical in health supplements. So how do we put the E. coli in our device? Well, our well-constructed E. coli is coated on the scoring pad. It may sound hilarious because you can get scoring pad easily in everyone's kitchen, but it do act as a perfect shelter for E. coli. Therefore, it is actually commonly used in a lot of research. After coating the E. coli to scoring pad, they will be put into the groove in our device. The grooves can slow down the water flow, enable E. coli to work safely and efficiently. Now, the nitrate has been removed, so the water will flow out from the regulation box and then undergo another filtration process to remove all the E. coli in it. First, the coarse filter will block bigger impurities, and then the water pump will push water through bacterial filter. Theoretically, all the E. coli will be filtered at this step, but we are not going to take any risk since biosafety should be taken in the highest consideration. Thus, we use UV light to eliminate any single E. coli escaping from bacterial filter. Now let me introduce the true data we collected from our regulation system. We put nitrate into the water and kept the device working for 12 hours. As you can see, 50% of the nitrate has been removed in 12 hours. So, what about the biosafety? No problem. Let's take a look at the results of biosafety test. The plate on the left was applied with the water collected at the exit, directly without any filtration and UV process. The plate on the right was applied with water which went through bacterial filter and UV light. Clearly, our filtration system can trap E. coli in the device without fail. So, we have proved that our regulation system can remove nitrate in the water and turn it into glutamine, and the filtration process can ensure that no experimental bacteria can escape from our device. That's the regulation system of our No Problem project. Thank you for your watching.